So the web audio API program that I'm working on to transfer data over audio signals has actually progressed. I'm actually sending 128 bytes of characters now. And if I put this on listening, you'll see I have 23 channels that I'm listening to, or 24 actually. It starts at 0. And I've got another graph down here that actually shows me the data for each individual channel of if it's coming across as a 0 or a 1. This is going to take 2.5 seconds and it's going to be noisy, so be prepared. I'm going to be quiet. Bam! Look at that. So each of these channels matches up with a segment. So I'm actually listing out the index of the segment. So it's going from 0 to what, 67 or something like that. Uh, and it's showing me which ones have a problem. Now, sometimes when I play with different frequencies, I can actually see a pattern across the whole horizontal channel for that specific channel where there's a lot of red for some reason. Uh, Often, if I'm just talking, my voice has certain frequencies that do interfere with it occasionally. Okay, so another problem I'm having is if I scroll down received, you're going to see a lot of red. There we go. See all that red? That's not reflected down here. There's something out of sync. I mean, it's all in sync up here. So I have this third set of bits. The first number is wrong. So that's what I see down here. And I can match up all these to all these red bits, but then down the line something gets out of gets crazy or something. And so I'm just trying to figure out where I'm messing up. I'm calling the same function between how these bytes are captured as well as how these bytes are or bits are evaluated. The only difference is these bits are captured during runtime as they come in, whereas with the canvas, I'm looking back in history of an array of data, and so there's something going on between the two, even though it's the same function that they call that processes that logic. Uh, what else? All the channels have a different color now, and they are actually represented in their colors up here, which with 24 channels is very difficult to see. Uh, at the top here is also the number of samples that each segment was able to capture to figure out um, what bit was actually being represented. Now I can scroll down here and you can see I'm already at 800 baud, which is a major accomplishment for me. I would like to get the effective baud rate up to 550 at least, because that's the effective baud rate that my first tape drive for my first computer worked at. So it's like a miniature goal that I'd like to acquire. I could get there just by turning off error correction and bam, I'm there, but then my data is unstable. If we want to look at these frequencies easier, I'm going to reduce it down to 2 channels. And then I'm going to go back up here and change this to just say hello. And then we're going to change our segment count to 45. And let's see what comes across. Okay. So now you can see that we have 2 channels, and there is a solid line and a dotted line for each channel. The colors match to represent the high bit is the solid blue, and the low bit is the dotted blue. So you can see in this here number 29, the low bit is higher than the high bit. So this is a 0, and that's a 1, a 0, a 1, a 1, a 0. And you can map them between the channel information you see down at the bottom and what's actually at the top. I do need to take care of this font when there's only a smaller number of channels. Right now the font is based on the height of the channel and did not consider the width of the segment. Yeah, but you can see there's one specific channel that has an issue of transferring data for some reason. And it's definitely showing up. What else? I think that's the majority of what's been going on. Yeah. So I'm gonna leave off with that.